Good evening, everyone. My name is Arjinder Singh Khalsa. Today, I like to present on topic Cloud Security Design Principle. So, as we know, all know that in cloud, we face many unique security challenges like data breaches, unauthorized access, and insider threats, to name a few. To counter these, we rely on some set of foundational security principles. Let's go through each one of them and see how they protect our cloud environment. So, first, let's talk about the controlling access. In the world of vast cloud resources, we not everyone need full access. If I am a normal user of a system that only fetches or view data of a system, it's not my job to manage users like adding or removing other users, giving them roles, or other tasks that are done by admins. So I can perform my work without admin access. That brings us to the principle of least privilege. That says granting user the minimum necessary permission so that they can perform their tasks. This principle is all about giving users only the permission they need for their task. If a breach occurs, the attacker has a limited access and they can't access more than necessary. For example, we can have an analog example like a developer may only have permission for the development databases while production data remains out of his reach. By enforcing least privilege, we keep our environment secure by keeping access tightly controlled. As we can see that we can remove access and as we can have employees and an admins. Employee can have some other dashboards that he can access, but he does not have access to admin as they can perform their task without admin access. So as you know, in cloud operations often involves multiple sensitive tasks from handling data to managing finance. But what happens if one person has too much control? That brings us to the separation of duties, which tells us that distributing critical tasks among multiple individuals to prevent fraud and errors. Like we separate the duties between multiple peoples or multiple authorities, which helps us secure it more. So this principle divides critical tasks so that no single person can complete a sensitive process alone. This prevents fraud and reduces errors. Imagine approving a high value transaction with this principle. Two different people would need to authorize it, create checks and balance that enhance security. As we can see that here's the example of procurement system. If if a user has a transaction initiated a transaction or we can say file an expense or something, the procurement process has multiple stages and it go through multiple duties or we can say multiple authorities uh, till its final stage, that is the general ledger. So as we know, the cloud is very vast. In cloud security, having one line of defense is rarely enough. So we have the principle of defense of depth, which tells that employing multiple layer of security controls to protect against various threats. And the principle uses multiple layer of security to protect us against the various threats. It's like having several locked doors before you reach the valuable or the last room. Even if an attacker breaches through one layer, the other defenses will stand strong. For instance, a cloud environment might have firewalls, encryption, and access control layer together to safeguard the sensitive data. We can have an example of like using firewalls, intrusion detecting system, encryption, and strong access control to safeguard a cloud environment. So as we know, failures are inevitable, but how we handle them and make all the difference. That's why we use the fail-safe principle. As we know, if we make any system, we got to have failure in some parts of the system. So we have a fail-safe principle that tells us that we should design a system that should fail in a secure step if it fails. So as we can see, this principle ensures that when the system fails, they default to a secure state, minimizing risk like data loss or unauthorized access. They should not just shut down and it stops all the work, but they should be shut down or fail to a secure state so that there's no data breaches or data loss. By planning for safe failures, we can stay secure even during unexpected issues. As we can see the example when we enter password, if the password is wrong, the system does not fail whole. as a whole, but it should throw error, and it shows us the prompt that the password is wrong. So in cloud, simplicity can be a powerful tool in security. That's where the economy of mechanism principle comes in, which tells us that keeping security mechanism simple and easy to understand. This principle focuses on keeping security system simple and manageable. Complex solutions can be introduced, new vulnerabilities, while straightforward design are easier to secure and maintain. For example, a basic, strong password policy can often be more effective than one that is complicated and hard to follow. By keeping these simple, we reduce the risk of errors. Like if we can see this funny meme that says that it's uh, better than building a $1 million cluster to crack someone's laptop. It should be easier to drug them and beat them with a $5 wrench to get their password. Let's bring us to the sixth principle. As we know, in the cloud environment, every access attempt is an opportunity for potential misuse. So we use complete mediation to ensure all access requests are controlled and monitored. So we have the complete mediation principle that tells us we should enforce a strict control over all access requests. This principle means that every access request is authenticated and authorized. For instance, an identity and access management system checks each login attempt to make sure the user is verified, and that it should enter only the specific user that they have verified. That are verified with the system. With complete mediation, we prevent unauthorized access and keep our cloud environment safe. We can see an analogy example of a kernel of a operating system, or we can say that Linux, the TCB, that makes sure that no protected resource could be accessed without going through the TCB. So when it comes to security design, transparency can be a strength. This leads us to the open design, which tells us making security designs and algorithms publicly available for review and analysis. By making security design and algorithm publicly accessible, we invite the broader community to help identify and address vulnerabilities. Open source framework are a great example. By allowing public scrutiny, we improve our security faster than we could on our own. We have some example. We can see that there are many security frameworks and tools available open source. So shared resources in cloud can create risk. If we have a shared resource which can be changed by multiple people or shared by multiple people, if one of them gets hacked or some data breach, one of them has data breach, it can affect that resource and affect whole on other peoples also. So we have the least common mechanism principle to address this, which tells us minimizing shared resources and access path. We should minimize the resource sharing and access path between the users. This principle focuses on minimizing shared resource to reduce the chance of unauthorized access or data leakage. For example, network segmentation can isolate sensitive data, limiting access paths and strengthen security. You can see that example is segmented networks and isolation critical systems. There are multiple systems that are isolated and have only specific user that can access that systems. Which brings us to the next principle. Security measures that are hard and often used often get bypassed. To address this, we have the principle of psychological acceptability. Designing user interfaces that are intuitive and easy to use. This principle says this. This principle emphasizes making security features intuitive and user-friendly. When security is easy to follow, a clear instruction or simplified multi-factor authentication, users are most likely to stick to it, reducing risky behaviors. It brings us to the next part, that in any security system, the entire setup is only as strong as its weakest point. This brings us to the weakest link principle. which emphasize recognizing that overall security of system is only as strong as its weakest component. By identifying and addressing our most vulnerable areas, we can shore up defenses and prevent easy breaches. For example, prioritizing updates on critical systems ensure that we are protecting the likely part that are to be targeted of a system. So example is prioritizing security patches or parts that are targeted mostly. Finally, why reinvent the wheel? That's the idea behind the leveraging existing component, which tells us using proven security components and frameworks that are already designed or that are previously developed. So by reusing tried and true security components and frameworks, we save time and reduce risk. For example, using established encryption libraries lets us rely on the security of community vetted tools rather than building something from scratch. Established components are trusted and often well supported. That boosts our overall security. Like utilizing industry standard security libraries and tools that are mostly and properly built. So these principles guides us in building secure, resilient cloud system. By understanding and applying each one, we can better protect against today's threats while preparing for future challenges. Thank you for joining me on this overview of cloud security and design principle. See you later, guys. Thank you.